Okay, first of all, thanks for giving the opportunity to share with you this work that was part of my doctoral thesis that I finished in 2020, in middle of the pandemic. That's important to say that. Okay, regarding the objective of this work is to assess the effect of environmental variables and different control strategies on the population dynamic of Caligus rogercresseyi. So to go to this objective, it was necessary to develop the approach of the system analysis. And system analysis, first of all, was necessary to conceptualize what are the system of interest. In this case, is the site with the fish, with the environmental variables like temperature and salinity, with sanitary and productive practice. And beside, with our Lice, our Caligus, that are producing in the same site, and also are becoming from the neighborhood sites. So when we talk about this, I present you the study area that was located in the south of Chile in 10 regions. I use 3 Salmon neighborhood area, S and A, according to our legislation. And Salmon neighborhood area is a group of sites that share common characteristics like oceanographic, epidemiological, and geographic characteristics. And you can see here the 3 areas with the site that were part of the study. And regarding the system analysis and simulation, it's important for me to present what are the steps, because the system analysis simulation is the same when we talk about the scientific methodology. The first step is the conceptual model that I can say that we should be included in the interest system. We need to define the border of the interest system. What are the main relationships that we can study? Which behavior pattern that can be projected in our study? The phase 2 is the quantitative model, when we translate the conceptual model into mathematical equation and solve it. And when we talk about the mathematical equation, I use differences equations. The phase 3 is the evaluation of the model. If the model is appropriated with the proposed defined in the study, what are the component relationship and predictive of the ability of the model? And finally, all the important aspect is the sensitivity analysis. And the last part of the system analysis is the use of the model, when we try to answer the initial question, design and simulate it, analyze, interpret it, and finally communicate the results. This is the conceptual model. I present as a simplification of the model, because the model that I work, it was very, very complex. But I tried to summarize in this, and I present this. I work with 4 submodels. First was the development time per stages. Second, the free living stages. Third, the host infestation. And finally, the developed on the host. All of them are connected between them, as you can see, for instance, with this arrow. And regarding the quantitative model, as I mentioned, was developed using difference equation that appear here, for instance, for the submodel free living stages, and the sort of this difference equation was using different information that was used to parameterize the equations. That you can see, for instance, here, that are the source of information that I can use. Regarding the quantitative model, regarding the 2 important variables for this model, that was the temperature and salinity, I present you what are the patterns of the temperature and salinity in the 3 S and A that was entered in the model as a time series. And other important variable is the infestation rate And the infestation rate, I assume that the infestation rate will be maximum when we have 25% of the infestation rate, when the sea lice on fish is 0, and 0 infestation rate when the load on the fish is equal to 100 sea lice per fish. What as the main step of the evaluation of the model, I present this scheme. Well, I work first was the model structure and functional relationship. Second part was the model behavior and expected pattern of the model prediction and data from the real system. And finally, the sensitivity analysis. When I talk about the sensitivity analysis, I refer that to do a little change in some parameter. What is the effect? And for example, here, I talk about the maximum infestation rate that I referred before, 25%, again, 50%. Regarding some data about the model evaluation, the development time and abundance, here you can see a comparison of the development time, comparing with this reference, González y Carvajal, that they describe the life of cycle of Caligus, and these are the output of the, these are the output of the model, and we can see here in this table that in general, our model was quite consistent with the reference in terms of the different development time for the different stage of the Caligus. And regarding with the simulation of the abundance of Caligus rogercresseyi, we can see here that the model can predict the survival and the abundance according to the different environmental variables that are part of the SNA. Regarding the results, use of the model, for example, here I work in the different combination of efficacy on adult and juvenile, using an efficacy of 90% on adult and 0% of efficacy in juveniles. And in the opposite way, I use 0% of efficacy on adult and 90% of efficacy in juvenile. It's not relevant, the product, but it's important. The main message is that the model can be useful for applying different strategies. And under this extreme condition, we can see that it's better to use product with high efficacy on juvenile than adult, because finally, we are affecting the molting process. And the other part of it is a combination of trigger level and efficacy on adult. In this table, I present different trigger level that we can use 3, 6, or 9. Just remember, according to Chilean regulation, it's mandatory to apply treatment when we reach 3 gravid female per fish. And using a different combination of adult, a different combination of efficacy on adult, like 90, 50, and 30%. And here we can see that if we increase the trigger level and maintain the same level of efficacy, for instance, 90% and here 90%, the model predicts that increase the amount of treatment that will be necessary. And in the other part, if we use the same, but showing what are the impact in the abundance in the population dynamic of the sea lice, we can see here, if we use the same, 90% of efficacy on juveniles, maintaining and 9 gravid female as a trigger level compared with the others with 3 gravid level, more total sea lice will be predicted according to the model. Finally, what are the main conclusions and remarks? this model is capable of reproducing cycle and changes the abundance patterns of Caligus rogercresseyi based on environmental conditions, as I mentioned, temperature and salinity. On the three SNA that I use of the study, in SNA 10A and 10B, higher abundance are simulated than 17A, and more treatment are carried out due to the optimal environmental conditions for the parasite. What are the theoretical implications and practical application of the model for the integrated pest management? Is the one, for us, it was quite relevant, this variable, the infestation rate, one of the less known parameters at the field level, with high impact on abundance and with difference between areas. And the infestation rate and fish size, we know that greater weight, greater surface area of the fish. And finally, change of our point of view and put our focus on the juvenile control. We know that sanitary practice and available information indicate that the gravid female are the engine for the control of sea lice. But in this case, fewer load will be produced on the fish when we put more focus in the control of the juvenile. For that reason, it's an invitation that change the focus on prevention. And finally, use of different trigger level in pilot area that can be proposed for future regulatory changes in the regulation. That's all. Gracias.